A few weeks ago, I released the No Compromise PC, the system built in the Laser LZ7, a really nice compact case, and it went really well. But I did get a ton of feedback in terms of comments of people saying I wouldn't be able to cool itself, I need to flip the PSU, all sorts of crazy stuff. So today we're gonna go ahead and take a look at the actual benchmarks. So if you didn't see the initial build, I would check it out. I'll link to it in the little eye in the corner, as well as in the description below. Before we get started, a quick side note. So a lot of you had commented on the build video that I should flip the PSU around and let the CPU cooler exhaust hot air through that and out the case. Well, there are a few reasons why I'm not going to do that. For one, I did try that when I first got this case with my original build, and it really didn't improve CPU temperatures much at all. For two, the Corsair SF450 is designed to be passively cooled most of the time. So the fan can spin up when it gets warm, but generally it's passively cooled, not making noise at all. When you flip the PSU around and let the CPU cooler put hot air through it, one, it's warming up the components and it's constantly making the fan ramp up and down. So normally when I'm gaming, the fan isn't even on. It really only comes on when I do renders. So 90% of the time it's completely silent. When you flip it around, not the case. Constantly modulating the fan, going up and down, it's pretty annoying, and that's not something I'm really trying to deal with. I'm trying to keep the system as quiet and compact as possible. So as I mentioned in the video, I am running the CPU at 5 gigahertz. With the Asus BIOS, it's really easy to overclock the CPU. So I'm hitting 5 gigahertz on all cores at 1.36 volts. And after some fiddling and testing, I was able to push the GPU clock on the 1080 Mini up to 1943 megahertz. This configuration, while it seems a little bit crazy, it works, trust me. So let's take a look at some of the CPU benchmarks first. Overall, this system killed in CPU tests. It really flew. Obviously, the Cinebench score is right in line with what you would expect to see from an overclocked 8700K. Everything else is right in line with where it should be. I was a little more interested in the GPU test. 5 gigahertz overclock 8700K is going to pretty much perform in the same ballpark for every chip. But the GPU being a 1080 Mini, I was interested to see how this system actually performed for games, and I was pleasantly surprised. Looking at some of the synthetic benchmarks for the GPU, it really flew through pretty much most tasks, getting all the performance you would expect from a 1080, especially if you look at the TimeSpy and 3DMark scores. So it's right there. I'm getting monstrous performance from this really compact system. Next up, let's take a listen to a noise test. The system did really well in this test. It's not the quietest PC I've ever built or heard, obviously, but it is very quiet, especially when gaming. It's not too crazy loud. So first up, we'll listen to the system at idle, then we'll slide over to gaming, and then to really push it, we'll do a rendering test. So as you heard and saw, it does not get super crazy loud. It really never peaks over 50 decibels. So it's very comfortable even when doing a full 4K render, pushing the GPU and CPU. It's pretty decent in terms of the audio quality. Now, if you want the quietest system on the market, that's not going to be that. It does generate noise, but while gaming, it's really not too loud at all. The fan on the 1080 Mini doesn't have to spit up past around 60–70%, so it keeps the audio levels in check, and I was very pleased with it. Another big question a lot of people seem to have is about power draw. So I set up my watt meter there. As you can see, this is at idle, so we're pulling around 47, 48 watts at idle. And then we're going to slide it up to gaming. So now during a gaming test, we're running around 250 watts, between 250 and 260. It's pretty consistent with what I would expect from a 1080 and an overclocked 8700K. So now I'm running a full system stress test with FurMark. The CPU is being pegged at 100% on all threads, as well as the GPU. And you see the system is pulling around 350 watts from the wall. That is why you're able to get away with a 450 watt power supply. You do not need the 600 watt. This is plenty of juice for this type of system. I'll admit, when I built this system, I was not anticipating being able to do a full 5 gigahertz overclock in this compact case. I know that it cools really well, but I was a little concerned. Luckily, this case outperforms pretty much any compact case I've used to this point. That massive 140 millimeter side intake fan really does a great job cooling everything in there, and there's exhaust all over the place. So keep in mind, there's an exhaust port underneath the PSU, there's an exhaust port on the whole top of the case, there's an exhaust on all 5 sides of the graphics card. So there's really exhaust everywhere. There's a lot of places for hot air to get out of the case, which really helps when cooling this CPU and GPU. So at idle, this system sits at a comfortable 33 degrees Celsius. Really nice temperature at idle for an air-cooled system. No problems there. When gaming, we step up to only around 65, 64 degrees Celsius, depending on, obviously what you're doing, it'll fluctuate. But my system never really peaked over 70 degrees. Even on the temporary spikes you see, it's not gonna go much past the 60s, which is phenomenal. So at 5 gigahertz, you're getting a 64 or 65 degree temperature with this compact case. That's amazing. Okay, here we have the system set at idle. You can see the live temperatures from a hardware monitor sitting at 33 degrees idle right now. 5 gigahertz on the clock, the max boost speed there. So I'm gonna go ahead and open Heaven. We're gonna run it in full screen mode, or actually, I'm sorry, windowed mode, so you can kind of see this live. I'll run Heaven with the live hardware monitor there. We'll just let it run for about 30 minutes so we can get a good test and idea of what's going on here. So we have currently the GPU clocked at 1949 according to Heaven, and at 44 degrees, and the CPU is currently pegged at around 50, so 48, 50. So we'll come back in around 10, 15, 20 minutes, and I'll show you where we're at. All right, so this has been running for about 20 minutes now, and we can see our temperatures are sitting in the high 50s, touching the low 60s sometimes. Right now, hovering in the high 50s. It's pretty consistent. You can run this for however long you want, a couple hours. It's not gonna get heat soaked and start going crazy with the temps. It is very consistent. I know what you're thinking though. This is a synthetic benchmark, so let's actually try a real world game that may be a little more demanding on the CPU. Let's slide over to The Witcher 3. This is all obviously set up to at ultra settings, so I'm trying to push it as hard as I really can with the 1080p setup. So playing around with The Witcher 3, you see the temperatures are still in the same spot, hovering in the mid 50s, high 50s and low 60s. We've seen a peak temperature spike of 73 C, so that's as high as it went the entire time we were running both Heaven and The Witcher. This is a really good system for gaming. It doesn't get crazy loud, and the CPU has no problem being cooled by this setup. Now, rendering in Prime 95 is where we do see a little bit of a hiccup. While we're not hitting thermal max, it is hotter than I would like it to be. Now, some of you are going to say 92C for rendering, that's too high. Sure, I agree with you. It's not the most comfortable of temperatures. Now, it is stable. It's not gonna go above that, but what I've really done is I created a second overclocking profile in the ASUS BIOS. So now I generally run at 5 gigahertz gaming, everyday tasks, 95% of the time. But when I'm gonna do a render, I pop into the BIOS to activate the second profile, which drops the clock speed down to 4.7. And that gives me stable high 70s, low 80s for render and Prime 95 super intensive CPU tasks. Another thing you can do is set the AVX offset in your BIOS to a 3 or 2, whatever you feel comfortable with, and drop the temperatures that way as well. I think the next step for me in this system will be doing a D-lid and dropping the temperatures down even more so that I can run 5 gigahertz all the time and never touch 90C. So can you run an overclocked 8700K and 1080 Mini in this case? Yes, you absolutely can, and it will be completely stable as long as you're doing it right and you're not doing anything crazy and you have proper ventilation in the case. So those are the benchmarks, guys. Overall, I think the system is a monster. It performs admirably. The cooling is very good, especially for a compact cooler. That Noctua cooler, man, there's some magic going on there. As always, I'll drop links to everything you've seen in the video, as well as a link out to the review on the website. You can see all the benchmarks listed. If you want me to do any more testing or anything, just hit me up. I can add it to the article always. That's why it's great having a separate website as well. I will be back very soon with some fresh new cases and builds like this one right here, which I teased on Instagram to some of you guys that you saw. This is gonna be very exciting. Another awesome compact case. So look out for that in the coming weeks and more videos. Thanks for watching. Please like, comment, and subscribe if you liked the video. I'm Jay, this is Tech Everything. I'll see you next time.